Hello everyone, today we're going to talk about addition and subtraction of surds. First of all, let's consider these basic properties of surd. So these are the basic properties of surd as we discussed in our last class. I'll put the link of the last video at the description below so that you can check it out. We said that if we have example surd 2 times root 3, we can multiply them as square root of 2 times 3, which gives us square root of 6. In the same way, let's say we have two same radicals, like square root of 7 times square root of 7 is going to give us the original number beneath the square root, so which is 7. In the same way, if we have square root of, let's say, 125 divided by square root of 5, it can be rewritten as square root of 125 divided by 5, which is equals to 125 by 5 is 25. We do know that 25 is a square number. Therefore, the answer is 5. In the first video, we covered what are square numbers. So you can check the link below and review square numbers. All right, now let's continue. Let's come to the addition of surd. Surds can only be added if they are like terms. For example, square root of 3 plus square root of 3. We have one square root of 3 and another square root of 3. Therefore, we will get 2 square root 3. It's just like a plus a. A plus a, which gives us 2a. Is the same thing. But mind you, a plus c, we cannot combine it. It's just like trying to combine apples and oranges, right? So this remains a plus c. Let's do more examples. Root 7 plus 2 root 7. Since the terms are the same, look at the radicals. We have 1 square root of 7 and 2 lot of 7. Therefore, we're going to have 3 lot of root 7. That's it. How about if we have 3 lot of square root 2 minus 2 square root 2? It's the same thing. Let's subtract the whole numbers separately, which gives us 1, right? But for 1 times the root 2, we're going to have root 2. No need to write the 1 like that, no need. All right. Let's try to solve this together. 2 root 5 plus 5 root 5. I guess you know the answer already. 7 root 5 is the same. How about this one? Let me go up a little bit. Let's add the following. 1 2 root 3 plus root, let's say 27. 2 square root of 8 plus square root of 18. Let's add the minus square root of 2. Let's see this. So for the first question, this is the same as 2 root 3. We cannot further break down this set, but we can do something about square root of 27. We know that square root of 27 can be broken down as square root of 9 times 3. So we come here, 2 root 3 plus square root 9 times square root 3, which is 2 root 3 plus square root of 9 is 3 times root 3. We come again, 2 root 3 plus 3 root 3. Here we go again. You find out that this here is the same as what we did up there. This one is the same as this one. We have two like terms. The radicals are the same, root 3, root 3. Therefore, we can combine the whole numbers, which is 5. 2 plus 3 is 5, root 3. Done. Root 8 can be rewritten as root 4 times root 2. How about root 18? Square root of 18 again can be rewritten as square root of 9 times square root of 2. Since we cannot further simplify root 2, we leave it like that, square root of 2. We know 4 is a square number, so square root of 4 is 2, which is times 2. So it's going to give us 2 root 2, then plus square root of 9 is 3 times root 2, giving us 3 root 2 minus root 2. Again, we have our like terms. The radicals are all root 2, root 2, root 2. Therefore, we can do a simple addition and subtraction here. We have 2 root 2 plus 3 root 2, which is 5 root 2 minus root 2. Don't forget, here we have 1 here, but we don't write. We know it's 1 of root 2. This is 5 lots of root 2, and this is 1 lot of root 2. So 5 lots of root 2 minus 1 lot of root 2, we're going to have 4 root 2. Done. Let's practice more examples. 2 root 8 minus 3 root 32. How do you solve this one? Number 3 and number 4. 3 root 75 minus root 12 plus root, let's say, 108. How do you solve this problem? 2 square root of 8 is 2. Then root 8 alone can be simplified as square root of 4 times square root of 2 minus 3 and root 32. Root 32 can be simplified as root 16 times root 2. It's the same thing. 2 times 16 is 32. So root 2 times root 16 is root 32. Nothing has changed. Let's move on. So we have 2, this one, multiplied by root 4. Root 4 is 2. So 2 multiplied by 2. Then times root 2 minus 3 root 16 we know is 4. So minus 3 times 4 times root 2. This gives us 4 root 2. 2 times 2 is 4. Minus 12 negative 3 times 4 is negative 12 root 2. Here we go. Like terms. Therefore, we can add or subtract. So 4 minus 12, negative 8 lots of root 2. That's it. Done. How about question 4? Let's see what we can do about question number 4. How do we tackle this in the first place? How do we tackle this one? We know all these roots, 75, root 12, and root 118 can further be simplified. So let's go. This is equals to, we can, okay, let's bring our 3. Root 75 can be written as 25 times, 3 times square root of 3. Then minus root 12 can be written as root 4 times root 3. How about root 108? 3 times 36 will give us 108. So we can write it as root 36 times root 3, which is equals to, please, let me sign a caution here. Again, I've already done a video about this. Why I chose or I decided to pick a factor and a square number. So this is a factor of 102, but at the same time, it's a square number. Same as this 4, which is a square number and a factor of 12. 25 is a square number and it's also a factor of 75. That makes things simple. So you can go back and watch that video. I'll put the link below. All right, let's move on. So 3 times root 25 is 5. So 3 times 5 times square root of 3 minus square root of 2, square root of 4 is 2 times root 3 plus square root of 36 is 6. Is 6 times root 3. So 3 times 5, 15 root 3. 3 times 5 times square root of 3 minus 2 times 3 is 2 root 3 plus 6 root 3. Again, we have like terms here. All the radicals are root 3. Let's continue. 15 minus 2, 13 root 3. But we haven't finished. We still have 6 lots of roots 3. 6 and 13 gives us 19 root 3. Done. Now consider this expression. Root 75 plus root 12. This is the same as the square root of 25 times square root of 3. And then root 12 can be written as root 4 times root 3, which is the same as 5 root 3 plus 2 root 3. We add them, we get 7 root 3. I hope it's getting better and better now. How about giving something like this? 1 plus root 5, all in bracket, then 1 minus root 5, also all in bracket. How do we simplify this? So the best way to do this is first expand this expression. So this one is going to multiply this one, and then after that it goes on to multiply the root 5. After that we multiply this 5 also by this one, and 5 by this root of 5. All right, so let's start. So 1 times 1, this one times 1. So let me even write the whole thing, the whole process. So you're going to have 1 times, or you're going to multiply it like this. Okay, I think this approach will be better. So this one is going to multiply 1 minus root 5. After that, this root 5, we're going to use it to multiply, but it's positive, right? So this root 5 is also going to multiply 1 minus square root of 5, like this. So let's go. 1 times 1 is 1 minus square root of 5. Nothing has changed. We just multiply everything by 1. Then plus root 5 times 1 again is root 5. Root 5 times negative root 5. Don't forget root 5 times negative root 5. We have, this is root 5 and this is root 5, but it's going to give us negative 5 because same root 5, it should give us 5, but we have negative sign over there. All right, so this can further be, let me put my equal sign here. We know 1, we've written 1, but look at something that's happening here. Negative root 5 can take away positive root 5. It's the same thing as minus 2 plus minus 2 plus 2 is equals to 0. So this can cancel this. It's the same. So negative root 5 will take away positive root 5. We just cancel out. We're going to have 1 minus 5, which will give us negative 4. That's it. Let's extend this idea. I'm going to give our last set of questions here. Question number 1. If you are given 1 plus square root of 3 or squared, how do you do it? Question 2. 4 into bracket square root of 7 plus 3 square root of 5 minus 3 into bracket root 7 minus 2 root 5. Let's come here. We know for us to solve this one, we can again expand this. So 1 plus root 3 all squared. It means that we're going to have 1 plus root 3 multiplied itself. 1 plus root 3. you'll find out that this actually is the same as what happened here. So you're going to use this same technique. First, you multiply the 1 by that, and then also the 5 by this. So you're going to apply the same technique to complete this one. This one multiplied 1, we're going to get 1. This one multiplied root 3, we're going to get plus root 3. Let's come to root 3. Root 3 times 1, we're going to have same root 3. Root 3 times root 3. Root 3 times root 3 is going to give us the original value. We have two like terms here, and we have that. All right, so let's add the whole number separately. 1 plus 3, we're going to have 4. Root 3 plus root 3, we're going to have plus 2 root 3. Right? This one we cannot further simplify it because they are not like them. This is a whole number and this is a set. Therefore, we have to leave it like this. Let's quickly solve this question. Again, we're going to multiply this expression by 4 and then this expression by -3. Let's quickly do that. So this is going to be same as 4 root 7. 4 times 3 is going to give us plus 12 root 5. Then we come to -3 times root 7, which is -3 root 7. Then negative. So this is going to give us positive. So you're going to have 6 root 5. Let's continue, which is the same as, do you have like terms? Yes, like terms exist. So we can, you see, 4 lots of root 7. Then we have -3 lot of root 7. So we can do something about these two. 4 minus 3 is 1. And we don't need to even write the 1. We just write root 7. How about 12 root 5 and 6 root 5 addition? So here we're going to get 18 plus 18 root 5. So at this point, we can't further go down again because they are not like terms. We can only add them when the radicals are the same. In this case, we have 2 different radicals. Therefore, it cannot be added. Now, let's solve our last problem. Root 2 plus root 3, or in bracket, then we have 2 plus 2 root 3, also all in bracket. Think about it. It's similar to what you've just done earlier. So we take root 2 root 2, and we multiply root 2 by root 2 plus 2 root 3. After that, we take root 3 and do same. So you multiply root 3 by same root 2 plus 2 root 3. This is the same as, because of this space, let's skip some of the procedures. So 2 root 2, we know is 2. Root 2 times 2 root 3. It's going to give us plus 2 root 6. Done. Let's go to this part. Root 3 times root 2 is going to give us root 6 plus root 3 times 2 root 3 is going to give us 2 times 3. Now you see we have some like terms. All right. So we can add these like terms here. We know 2. Let me write 2 plus, we have 2 lot of 6 plus 2 lot of root 6 plus root 6, which is 3 lot of root 6 plus 2 times 3, which is 6. So our final answer is going to give us 8 plus 3 lots of root 6. And that's it for the entire lesson today. Thanks for watching. You may consider to subscribe to my channel. Thank you.